In lesson 1.3, we're going to be subtracting integers. We're going to model this the same way we modeled adding integers, where we'll use both the two-sided chips and making zero pairs, and we'll use the number line. So first we're going to use the two-sided chips. Remember, the red represent negatives and the yellow represent positives. So in example A, where we model -4 minus -3, we're going to start with 4 red counters, and then when we do subtraction, we do it a little bit differently. We're going to think of the subtraction sign as take away, and we need to take away 3 negative pairs. Now, because they have the same sign here, there are 3 negatives to take away. So notice how they just took away 3 red dots, and then there's 1 negative left. So we started with 4 negative counters to represent -4. We take away 3 negative counters representing subtracting -3. What is left? 1 negative counter. It's negative, so -4 minus -3 equals -1. Now in example B, we're going to model subtracting a negative from a positive. So we're going to start with 6. So start with 6 counters, that's these here. And then we need to take away 3 negative counters. But in our original 6, there are no negative counters. So we're going to add 0 pairs, that's what these are, until we get 3 negative counters. So we added 3 0 pairs. Then we take away the 3 negative counters. And now we can count how many positives we have. So we took away 3 negative counters. What is left? Well, we have the original 6 and then 3 positive counters. 6 plus 3 is 9. So 6 minus -3 is +9. All right, in example C, we're going to take away a negative that is more negatives than the original number we start with. So we're going to start with -2. So we start with 2 red counters. So here's my 2 red counters. And now we need to take away 5 red counters. So we're going to add 3 0 pairs. So I have 1, 2, 3. Those are all 0 pairs. All right, so now we take away 5 negative counters. Cross those 5 out, and how many are left? We have 3 yellow counters left. So -2 minus -5 is +3. And if you happen to add more negative pairs than you need, sometimes one of the questions might be, how do you know to add 3 0 pairs? Say I did add an extra 0 pair. I'll model that here. So say I added an extra 0 pair. Well, now I have 4 positives and 1 negative left. So just like when we were adding, we have to make sure one of those cancel out. So you're still going to be left with 3 positives, no matter how many 0 pairs you add. So it's okay if you don't add the right number of 0 pairs. You should still end up with the same answer. All right, so let's reflect on this a little bit. Suppose you want to model the difference -4 minus 7. Do you need to add 0 pairs? If so, why? How many should you add? And what is the difference? Well, let's set this up like we would in the last example. So we have -4 minus 7. We're going to start with 4 red counters. And -7 means you have to take away 7 positive counters. There are no positive counters here. So we would need to add 7 0 pairs. 4, 5, 6, 7. Make sure these are 0 pairs. We would need to add 7 0 pairs so that there's 7 positives there. And then when we take away the 7, so we take away those 7 positives, then I count all the negatives that are there, which actually looks just like -4 plus -7, which we learned how to do in 1.2, 1.1 actually. So the answer would be -11. All right, the second way we're going to model subtracting with negatives is on a number line. Remember when we subtract. When we move negative, we move to the left. When we move positive, we move to the right. So to model the difference 5 minus 3 on a number line, you start at 5 and you move 3 to the left. Notice you model the sum of 5 plus negative 3 in the same way. So 5 minus 3, this is a key fact here. 5 minus 3 is the same thing as 5 plus negative 3. Same thing. So we're going to use that fact that subtracting a number is the same as adding its opposite. I'm going to highlight that here. Subtracting a number is the same as adding its opposite to find the difference of two integers. So in example A, we're starting with negative 1 minus 5. Subtracting 5 is the same thing as adding negative 5. So I'm going to rewrite that here. Negative 1 minus 5 is the same thing as negative 1 plus negative 5. And now we can model it the same way we modeled addition. So I'm going to start at negative 1, and we're going to move 5 units to the left. So start at negative 1, move 1, 2, 3, 4, 5 units to the left, and our answer is negative 6. All right, so in example B, I have negative 7 minus negative 3. Subtracting negative 3 is the same thing as adding its opposite, which is positive 3. So we're going to rewrite this, negative 7 plus 3. You can write positive 3 if you want. We're going to start at negative 7, and we're going to move 3 units to the right this time because we're moving more positive. So start at negative 7, move 1, 2, 3 units. My answer is negative 4. All right, now let's reflect on this method a little bit. Describe how to find 5 minus negative 8 on a number line. If you found the difference using counters, would you get the same result? Well, of course you would get the same result using counters as long as you modeled both appropriately like we did in the examples. How we would find that using a number line. Subtracting negative 8 is the same thing as adding positive 8, adding its opposite. So we would just solve 5 plus 8, which is 13. And if we were to do this with counters, we would start at 5 positive counters, and then we would need to take away 8 red counters. There are no red counters, so we have to add 8 zero pairs. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to add yellows to make 0 pairs. And then we take away 8 red ones. So I'm going to cross out these 8 red ones. There are 13 positive counters left, meaning 5 minus negative 8 is 13. So you get the same answer no matter which way you model it. So while you're doing your homework, I would like you to use whichever way you're most comfortable with. You can try using both. A couple problems will walk you through using both, but in general, use whichever method works better for you. All right, before we move on to the homework examples, I would like to use a real-world problem here. So we're going to subtract integers by adding the opposite, just like we did in the last example, but we're going to be using temperature. So here is our word problem. The temperature on Monday was negative 5 degrees Celsius. By Tuesday, the temperature rose to negative 2 degrees Celsius. Find the change in temperature. Well, a number line would be most appropriate here to model the change. So here's my little thermometer, and I have negative 5 way down here, and it rose to negative 2. I want to know how much it rose to get to negative 2. So we're going to write a subtraction expression. Negative 2 minus negative 5. We're finding the change or the difference from negative 5 to negative 2. And then to find the difference, we're going to add the opposite, just like we did in the last one. So negative 2 minus negative 5 is the same thing as adding the opposite of negative 5, which is positive 5. So negative 2 minus negative 5 equals negative 2 plus 5. And now if we set it up that way on a number line, we start at negative 2 and then we move 5 units up. We're going to end at positive 3. The temperature increased by 3. So notice how we got 3 both ways, whether you see how many you count, like in this problem, you count by 3 to get from -5 to -2, or if I start at -2 and I add 5, I'm still going to end at 3. That was this way here. So either way, whether you're subtracting the negative or you're adding its opposite, you should get the same answer. All right, so let's reflect on this a little bit. What if, in example 1, the temperature rose by 3 degrees? Suppose it fell from -2 to -10. Predict whether the change in temperature would be positive or negative. Well, if it fell, the change would be negative. If it rose by 3, the change would be positive. And to subtract to find the change, that's going to be just like what we did here first. So subtracting to find the change, you're going to get the same answer. All right, I want to run through a couple more examples before I tell you what your homework problems are. So look up here at this your turn. Pause the video now, see if you can do all 4 of those by yourself, and then play it back to see if you got it right. All right, number 4. We have -7 minus 2. I'm going to set that up as -7 plus -2, which is -9. 3 minus 5. That one's easiest to think of on a number line. If I start at 3 and I move left 5, I'm going to end at -2. In number 5, I have -1 minus -3. Subtracting a negative is the same thing as adding its opposite. So this is the same as -1 plus 3, which I think is easiest again on a number line. So if I start at -1 and I move right 3, 0, 1, 2, we're going to end at 2, positive 2. And then in number 7, I have -8 minus -4, which is the same thing as -8 plus 4. This one might be easiest to set up counters to model because you have 8 red counters and then you add 4 positive counters, you cross out 4 zero pairs, and you're left with -4. All right, your homework today is going to be 1 through 13 odd, and then pick 2 between numbers 16, 17, 18, 19. Pick 2. So out of those 4, you're going to do 2, any 2. So you have numbers 1 through 13 odd, and then 2 of 16, 17, 18, 19.